Section 2.2, Properties from Algebra, Objective 5. Okay. In this section, we are going to go over the properties that you learned in algebra and how we use those in geometry proofs. Okay, so here's a warm-up. Solve this equation and justify each steps. Justify each step means to explain the reasons why you can do each operation. So here's the example. So here is the equation and you have to solve for x. So first thing you would do would be to move this negative 1/2 x over to the other side of the equation so the x are together. And on this side of the equation is just a number. So you'd add 1/2 x to both sides, so you get 3x plus 1/2 x equals 6. Now, you know you can do this, but why can't you? That's the question. So what you did was you added the 1/2 x on both sides of the equation because you can add the same number to both sides of an equation. That's why you can do it, right? Okay, so I want you to do the rest of steps and try to come up with your own words to justify each step. So stop the video here and do that and then come back, okay? All right, so what would you do next? You'd try to make this into one term, right? So you have to make a common denominator. So then you have to make this 6x over 2. And then you have 1/2 x equals 6. So only thing we did was we made the 3x into 6x over 2. And why can you do this? It's because you can multiply both the numerator and denominator by same number and it's still same fraction, right? So you can multiply both numerator and denominator by the same number. Okay, and then you would add 6x and 1x, so you get 7x over 2 equals 6. Now this is just the addition of like terms. So it's not really a rule. So this doesn't really need a reason. This is just what we did. And then what would you do? You want to get rid of this 2, right? So then you would multiply both sides by 2. So 7x equal 12. And that is, you can multiply both sides of equation by the same number. And then at the end, you want to make this just x equal, so you divide both sides by 7, and you have x equal 12 over 7. And the reason why you can do this is you can divide both sides by the same number. Okay, so this is the operation, and this is the reason why you can do it. And the proof works very similar to this way. So you have would be given. You will see this, it's coming up. Your first proof is coming out in 2, 2. So that's a given, and this is where you want to get to a conclusion. And these are the steps, and these are the reasons. Okay, so this is just a demonstration of geometric proof in algebra problem. Okay, so here is the whole chapter 2. We are here. Okay, and then this objective goes with first 3 sections. We have one objective in this section, number 5. Use properties from algebra and properties of congruence, you remember this sign for congruence, improves. Okay, so that's the objective, the only one objective for this packet. Okay, all right, so here comes the properties. Now, these properties goes with equality, which is this. And these three goes with the congruence, which is this. Now you remember the difference between this and this, right? What's the difference? This goes with the number, this goes with the figure, right? So these goes with the numbers, and this goes with the figures. Okay, so let's go one by one. Addition property, you can add the same, C and D are equal here, right? C and D are equal, so you can add the same number on the both sides of equation. Okay, so addition property is just you can add the same number on the both sides of equation. A equal B, and you're adding just C and D on both sides. The subtraction, you can subtract the same number from both sides. Multiplication, you can multiply the both sides of the equation by the same number, C. Division property, you can divide both sides of the number of the equation by the same number as long as the number is not 0, right? You can divide by 0. Substitution property, if A equal B, then either A or B may be substituted for the other in equation or inequality. So, for example, 2x plus y equals 6 or something, and 2x equals 3y or something like that. Then you can, I'm sorry, that's x equal, all right, x equals 3y. Then you can substitute 3y into x, and 3y plus y equals 6. That's a substitution. I substituted 3y in place of x to get this. So that's substitution property. Reflexive property, A equal A. Now, right now, you're thinking that doesn't make sense. But we need this property to do the proofs, and you will see it. It will come up in this section. Symmetric property, if A equal B, then B equal A. Okay, again, this looks too obvious, but we need this property, symmetric property. Reflexive is itself. Symmetric is if A equal B, then B have to equal A. Okay, and then transitive property is if A equal B and B equals C, then A have to equal C. Okay, so those are transitive property. Now, these three are the one that works for congruence too, but these three only. None of these works for congruency. These are only for numbers. These three also work for the congruence. The reflexive property, the segment DE is congruent to segment DE, segment D is congruent to segment D. Symmetric property, if the segment D is congruent to FG, then segment FG is congruent to DE. And transitive property, segment DE is congruent to segment FG is congruent to segment JK, then segment DE is congruent to segment JK. It's the same idea, works for the congruency. Distribution property, this only works for the numbers, the equalities as well, doesn't work for the congruency. A times B plus C is AB plus AC, that's distributive property. Okay, so here is the couple examples. So here you see that the congruent sign, right? So it only works for the last three, the reflexive, the symmetric, and transitive. Those are the only three that works for this, and this is angle P is angle P. So this is the first one, the reflexive property. So you can, so these are congruency, right? And all these are equality. I think you can do all this for homework. Okay, so we're gonna do these in video now, and after we do this, I want you to try these for homework. Okay, so let's look at this one. If 2x plus y equals 70 and y equals 3x, then 2x plus 3y equals 70. So the original was 2x plus y, and then we are putting 3x in place of y to get to this equation. So this is substitution. Property of equality. If AB equals CD and CD equals EF, and EF is 23, then AB is 23. So this is transitive property. Equality. So AB equals CD, CD equals EF is transitive property. And then EF equal 23. Okay, transitive, I'm sorry. So transitive property is this. AB equals CD and CD equal EF, and therefore AB equal EF. That's transitive property. And then EF is 23, so you substitute it into EF, and AB equal 23. So that's substitution. Okay, all right, so you do the rest. And here comes the first proof. And I have two examples, one for the segment and one for the angles. Okay, so the proofs are usually set up this way. You have the given, which is the accepted truth, and this is where you want to get to. The conclusion, destination, whatever you want to call it. Prove this, okay? And you get a diagram. You have the statements. This is the steps to prove to get to the conclusion. And these are the reason why you can do it, okay? So usually these are called two-column proofs, and most proofs are set up this way. Okay, so let's just understand. RS equal PS and ST equal SQ. So there's a tick mark here. Okay, so these are congruent and these are congruent, and that's given. That's from given. RT and PQ intersecting at S, so that, okay, it's intersecting in a way that this. So this is already given. Usually the given you're just copying into the first line and then say given. Now, RS plus ST equal PS plus SQ. That's addition property of equality, right? RS equal PS, and you just add in the same thing to the both sides. So you can do that, addition property of equality. And then RS plus ST equal RT. RS plus ST equal RT. And PS plus SQ equal PQ. That's a segment addition postulate. Now, all the postulate and theorems we learned can be a reason. You can use them as a reason for the proofs. Okay, so that's a segment addition postulate. And then RT equal PQ. RT equal PQ by substitution property. You are substituting these are, so this is the equation, right? And then you are substituting this RT into here and PQ into here to get to this. It's a double substitution in one step, but that's okay. All right, let's look at this one. Measure bango AOC equal measure bango BOD, and that's given. That's a given. And measure bango AOC is measure bango 1 plus measure bango 2. That's angle addition postulate, and equally the 2 plus 3 is BOD, angle addition postulate. Measure bango 1 plus measure bango 2 equal measure bango 2 plus measure bango 3 by substitution, because these are equal and these things are equal, so you can substitute it in here and in here, double substitution, they have to equal. Now here comes the reflexive property. This is how you use it. Measure bango 2 equal measure bango 2, they are the same, and therefore you can subtract the same thing from both sides. You have to say this to be able to subtract it. That's why you need this reason. And measure bango 1 equal measure bango 2 by subtraction property of equality. Okay. There are a couple of things that I need to go over to get ready for the proofs. The use of reflexive property. The reflexive property is good for both the congruency and equation. So you don't have to say reflexive property of equality or reflexive property of congruence. You can just say reflexive property, okay, because they are both. Reflexive property is good for the equality and congruence both. Okay, and substitution versus transitive. Suppose in the proof you have made the statement that measure bango R equal measure bango S, and also that measure bango S equal measure bango T. You can then deduce the measure bango R equal measure bango T, and use your reason either transitive property or substitution property, because you are substituting this into this, right, to get to measure bango R equal measure bango T, but also A equal B and B equals C, and therefore A equals C. That's a transitive. So you can use both reasons and you'll be correct as long as it's equal. Okay, as long as it's equal. However, when only substitution property works, if we are talking about the congruency, the only transitive works. So angle R is congruent to angle S, and angle S is congruent to angle T, and therefore angle R is congruent to angle T. This is transitive only, because the substitution doesn't work for the congruency. And also here's another situation. There are times when substitution property is the simplest one to use if you know that measure bango 4 plus measure bango 2 plus measure bango 5 is 180. And measure bango 4 equal measure bango 1, measure bango 5 equal measure bango 3, you can make a double substitution and get measure bango 1 plus measure bango 2 plus measure bango 3 equal 180. Okay, so the measure bango 5 is equal to 3, so 3 got substituted. Now the proofs in the previous page over here, these ones, and these ones, this one, this substitution property and this substitution property. These are double substitutions. You remember I said these are double substitutions. It only works for substitutions. It doesn't work as transitive. Okay, so that's what this is. Okay, in this case you can use transitive property here. Okay, so there are times that only transitive works, which is that when it's a congruency. And there are only times that there is only substitution works, which is when it's a double substitution. And there are other times that you can go either way. Okay, all right, so I want you to try filling out these answers as a homework. I think you can do this. All right, let's do these question mark, and then you fill in the reasons, and we review these in the class. Okay, so this is homework, except these we're gonna do in the video. Okay, so ST equal Rn, that's given. Okay, so let's just say that's given. That's how you always start anyway. Okay, so ST equal Rn, and also is there IT equal Ru? Yeah, IT equal Ru, that's a given. Okay, so SI plus IT is ST, right? So ST, that's ST. So you know what this reason is already. I hope you do. And RU plus UN is RN. Okay, so it's this, when these are the same reasons, and you can put the two things in one step, okay, because it's the same reason. And then they're equal, and they're equal, and at the end you want to get to prove. So SI equal UN, okay, and you fill in these reasons, and you do the same here, okay, and we will do this in the class, the rest of the packet in the class. So we are done. See you in the class. Bye.